Okay, let's unpack this. Today, we're diving into a source that, well, it dropped a connection that genuinely stopped us in our tracks.
Hmm.
It brings together two worlds you rarely see linked: mathematics and food.
Right. And specifically, the source uses this very particular phrasing, sensory calculus in food security.
Exactly. And it even drills down further, pointing to differentiation in food security derivatives in sensory analysis.
Hmm.
It's quite something.
That phrasing is certainly intriguing. We're used to thinking about food security in terms of things like physical access, economic affordability, nutrition,
Stability, yeah.
and calculus. Well, differentiation and derivatives, that's all about the mathematics of change, isn't it? Measuring rates, how things respond when something else varies.
Totally. So our mission for this deep dive is really to get inside what this source might be suggesting. What could it possibly mean to apply math concepts like differentiation, like derivatives, to the sensory side of food?
And specifically within that really critical context of food security.
Yes. And we're sticking strictly to the idea just as the source presents it.
Right. Because the source explicitly makes this link. It positions derivatives in sensory analysis under the broader umbrella of differentiation in food security. Now, it doesn't give us the actual formulas or
Yes.
variables,
No specifics like that.
but it names the connection. And sensory analysis is, as we understand it, is how our senses taste, smell, sight, touch, perceive food, often seen as pretty subjective.
Very subjective. And differentiation, well, that's the tool in calculus you use to find a derivative. And a derivative tells you the instantaneous rate of change.
Like velocity being the derivative of position over time, how fast your location is changing right now.
Exactly. And this is where the source's idea gets, well, fascinating.
It implies there might be a way to quantify parts of sensory perception or maybe food quality so you could measure its rate of change using calculus.
So, okay, imagine you have some way, maybe a scale or a measurement technique, to score, say, the perceived texture of a food item.
Mhm.
Instead of just one score, a derivative might tell you how quickly that texture score is changing,
Hmm.
maybe over time, or maybe as temperature or humidity shifts.
Precisely. And the source focusing on derivatives and sensory analysis within food security suggests that this isn't just like an academic exercise in quantifying something subjective.
Right.
It implies this rate of change in sensory attributes actually matters for whether food is truly secure for people.
Okay, but why would that matter?
Right.
Well, maybe if you're dealing with huge amounts of food, large-scale distribution, or long-term storage for food security,
Mm-hmm.
the rate at which food becomes less appealing, less palatable, or shows spoilage through sensory changes, that's critical.
Absolutely. If the texture degrades too fast or the flavor fades rapidly or, off odors develop,
Yeah.
the food might still be okay nutritionally, but people won't eat it. It becomes unacceptable, impacting utilization, maybe leading to waste.
Which is a huge problem in food security.
Exactly. So this raises a really important question the source seems to be nodding towards. Could understanding the derivative of a food's sensory profile, its rate of sensory decline, let us predict its acceptable shelf life better?
Or could it help figure out better storage conditions, ones designed specifically to slow down those rates of change?
That makes sense.
Imagine applying this. Let's say, the texture derivative of some grain under certain conditions tells you it gets noticeably stale after 3 months.
Okay.
But maybe under slightly cooler, drier conditions, the derivative is lower. The rate of change is slower and it stays good, stays palatable for 6 months. That's a huge win for logistics, for planning.
That's a very practical application. Or think about fortified foods, the ones crucial for nutrition programs.
Right, like adding vitamins.
If the flavor derivative shows that adding those nutrients makes the taste decline really fast, maybe over just a month, understanding that rate is vital.
Yeah, you need to know that.
It could push for different formulations, maybe different packaging, or just much quicker distribution cycles to make sure the food gets eaten while it's still acceptable.
So the source is putting forward this, well, powerful idea, even if it's a bit abstract right now,
Mm-hmm.
that using calculus tools, specifically derivatives to measure rates of change, might give us a more analytical, predictive handle on the dynamic sensory qualities of food.
And that this understanding is directly useful for the real-world challenge of making sure food is both available and desirable for everyone.
Yeah, available and something people actually want to eat.
It points towards a potential future where, subjective sensory evaluation gets augmented by quantitative modeling of how those qualities change over time or under different conditions.
Offering a new layer of insight for managing food systems, making them more resilient.
It really is an unexpected intersection, isn't it?
Totally unexpected. Linking precise mathematical measurement of change, like calculating a derivative, to something as variable as tasting or smelling food.
And all within the urgent context of food security.
It suggests that even in areas that seem purely qualitative, like sensory perception,
There might be these underlying mathematical structures, these rates of change, that if we could understand them.
could lead to significant benefits, real practical benefits, like cutting down food loss and improving access to quality nutrition.
So, wrapping up, what this source introduces is this concept that analyzing the rate of change in how we perceive food sensorially
The derivative of food quality, you could say.
using calculus isn't just theoretically possible, but potentially a vital tool for building a more stable, food secure future.
It really leaves you thinking, doesn't it? Could quantifying the dynamics of how food looks, smells, feels, tastes, measuring its sensory derivatives, truly unlock new quantitative strategies in the global effort to feed everyone?